What comes to mind when you hear the words artificial intelligence? Frankly, in your mind, you might be emphasizing the artificial more than the intelligence aspect of it, especially when you have responses like these, for example, from AI overview of Google, saying that elephants have 2 feet, rather than saying that they have 4, as any good zoologist would know. And of course, this is an issue for the public, that they have to trust that the AI is giving them the right answers. But frankly, public trust in AI is probably not as high as more optimistic people would think that it is when you get misinformation, disinformation, the potential of AI displacing jobs, everything negative that comes with it, the worry of too much dependence on it, and how it might replace original thinking and creativity, and frankly, when the way it is used is simply idiotic. The way that we use it tends to be more idiotic than intelligence. So what do we do with something like this? Well, this is not your brain after taking in AI content. This is something much more severe, much more serious. This is Alzheimer's disease and its effect on the brain. And you can see that it's basically killing the brain. It's eating away at it. And there's been, just like AI, a rise in the number in how often this is discussed. The prevalence of AI is increasing. In fact, the Alzheimer's Association predicts that by 2060, 6.7 million people ages 85 and older are expected to have Alzheimer's dementia, accounting for about half of all people 65 and older with Alzheimer's dementia. That is a frightening number, 6.7 million people, and that is just half of how many people above the age of 65 that have Alzheimer's. And there's still a few numbers to account for there. But you can see we need to be worried about where this is going. And frankly, for a disease that still has no cure, we need to figure something out on how to help these people. And this is where AI comes in, because there's been a rise in not only the use of AI and the prevalence of Alzheimer's, but also in that overlap between them, in the number of publications in scientific journals of how AI can be used to help with Alzheimer's. And in this case specifically, the way it is used is to help with speech detection, using AI to analyze the speech of people who have Alzheimer's. And where the overlap lies is in using it as a screening tool. I'll explain how that is used, and more importantly, why it should be used, why this is a vital tool that should be developed more. So of course, Alzheimer's, when it comes to mind, usually we are inclined to immediately think memory loss. That's the connection that we've established between Alzheimer's and the brain. And of course, that's not untrue. It's not wrong at all to make that association, but you need to realize that it's so much more than that. That it is not just affecting the parts of the brain that have to do with memory, but with the entire brain. And it affects other modalities of thinking, not just memory, but also reasoning, and specifically communication. And that's where AI comes in to help us understand Alzheimer's. That we know that communication skills can be classified in a way that if we can see a patient's ability to speak and to communicate, then we can classify that and know where along the continuum of Alzheimer's progression they are at. So different communication skills, their ability to read and write, or to speak in a fluid way without any repetition or stopping, understanding the words that they're saying and knowing how words can create sentences and paragraphs and ultimately create meaning and transmit messages to other people. Well, as soon as you are diagnosed with Alzheimer's, as soon as it starts taking effect in your brain, the early stages, well, you start having problems with understanding semantics, with understanding the specific meanings of words. And as you progress into the more moderate stage, impairments start becoming much more obvious. With, for example, a difficulty to remember what you were about to say. And you can see how memory can play into that. And also reverting to one's native language is something that is often seen in these patients. But also other struggles like understanding grammatic prosody, whether a statement is a sentence or a command or a question or an exclamation, or also the repetition of words and phrases and sentences. And once you get into the most severe stage, well, at that point, we can't really tell how much a patient could really understand what you're telling them. It's difficult to even tell. So the goal of using AI is to get input from a patient, use a model that can scan, analyze for acoustic features like speech rate, how many pauses they make, how many hesitations, and also for linguistic features like what's their grammar like? Is their syntax incomplete or broken? Are they repeating themselves a lot? Are they restarting lots of sentences or using lots of filler words? And get an output there of, does this person, according to the patterns of their speech, have Alzheimer's? And if they do, how severe is it? Where can we classify them along these stages of Alzheimer's progression? And you can see an example of such a program looking for different patterns in speech to tell, does this person have Alzheimer's or not? And you can see pauses per sentence in an Alzheimer's patient, of how many fillers, how many pronouns, using those simpler words instead of more complex words. And on the other hand, using longer sentences and expressing yourself more concisely and using bigger words is a sign that you don't have Alzheimer's dementia, that you are still in control of your mind, that you can still rely on more complex words and structures of language. But of course, there are limitations to technology like this. The first, technical errors and drawbacks. Of course, what is inherently wrong? What haven't we developed well enough in this program? And one prominent issue here is transcription errors, that the AI has to hear speech and turn that into text so it can analyze it. But if you've ever sent a voice message, or if you've ever used the transcription feature on your voicemails, you can see sometimes that is not at all what the person is saying. Of course, that is going to become a limitation. If the AI turns someone's speech into a bunch of words that don't make sense in that order, well, then it's going to understand that as this person doesn't understand that you can't use this word in this place, or they don't understand what this word means. So we have to worry about issues like that. And there's also the difficulty of communal development, or the difficulty of the science community at large coming together and saying, this is the direction that we want to go in with this program, or this is the aspect of this AI that we want to test. The research is really right now all over the place. People want to do their own thing. Researchers want to make their own code and aren't very willing to share it with each other so that they can create something bigger and better. And of course, the major ethical concerns, the distress, the concerns of informed consent, and even of discrimination. What if, for example, insurance companies start requiring their customers of older age to take a test like this, and if your results say that you are likely going to be diagnosed with Alzheimer's, then they're just going to raise your rates. Or the danger of someone anonymously getting a recording from someone in any range of a microphone, and automatically they have access to someone's sensitive medical information. Of course, these are limitations that we have to address, even if the program, the AI, is working perfectly. But the limitations really don't measure up to the advantages. Of course, one of the biggest advantages is the convenience of this without sacrificing accuracy. Nowadays, the best biomarker tests that we have for Alzheimer's consist of MRI and PET scans and blood tests. And that is invasive, and it is expensive and slow and laborious, and it can be very distressing for some people. This could be done very quickly and affordably, easily, without any invasive process, and it is very simple. It could simply require a patient to come in to a doctor's office, say, twice a year, or maybe even have the doctor go to the homes of these patients and administer the test there, and in a few minutes have results and understand where this patient is in terms of their Alzheimer's disease. There's also the universality of something like this, that there are certain patterns in the progression of Alzheimer's that are seen in communication that are language independent, that it doesn't matter what language you speak, the same patterns, the same, for example, pauses and hesitations and filler words, that's not going to depend on what language you speak. That's going to be present universally. And of course, there's also the issue of those ethical concerns that can be met. For example, if the worry is that someone is going to anonymously get sensitive medical information from someone, well, legislation can be put into place that limits this kind of technology to doctors' offices and hospitals, not make it a public app that everyone can access. Every single one of these ethical concerns that comes up has a way to be met. And specifically, being transparent about what AI is doing, what it's doing with your information, how it's using it, where it's going to go. If we want the public to trust in a tool like this to the point that we can implement it nationwide, maybe even internationally, it requires public trust. It requires transparency. And finally, the hope of future developments, that the AI will get better with time as more research goes into it, as more progress is made, and also the possibility of multimodal models, of not just using speech, but maybe pairing a microphone with a camera and tracking eye movements, for instance, while this AI is administering tests to know where a patient is in terms of their Alzheimer's disease. Well, ultimately, this is too useful an application of clinical technology to ignore. The advantages are too great. It helps doctors tremendously with addressing the needs of their patients if they know where they are in terms of how bad this Alzheimer's is with this patient. It helps the patient, helps the doctor, and it helps the families of those who are close to the patients to understand what's going to happen, especially with such a life-altering diagnosis, such a influential condition on everyone that touches you. And frankly, we can trust in tools like this while we wait for the scientific community at large to work to what is ultimately the cure of this infamous disease. Thank you. Definitely the cultural role there, that yes, it is universal, but of course there are nuances, not only with specific languages, but also specific regions even. They can be different. There is going to be small differences in it. And one of the worries with this AI potential limitation is that if you give it too much data to train itself on, you know, a wide variety of people, you might assume, oh, then it can help more people if it has more people to base itself on. But if you just give it more, then it loses nuance, and it only looks for very broad patterns in communication and language. So you almost lose certain details that that might help you understand even better where is this person in terms of their condition. But in terms of, you know, specifically this language has this specific pattern that appears, I didn't go that deep into it. But yes, there are different AI, I believe, that have been programmed to different languages to best fit each one.